If you have diabetes or your blood sugar keeps rising no matter how carefully you eat, I need you to stop for just a moment before you do anything else. Before you blame yourself again, before you swear off rice forever, before you throw out the bread, the potatoes, the pasta, every food you grew up eating, every food that feels like comfort, like home, like something your mother made for you, I want you to notice something first. Think about how you actually feel after eating carbohydrates, not just the number on your glucose monitor, your actual body. The heavy sleepiness that hits you 20 minutes after a meal, the kind where you can barely keep your eyes open at the table. The brain fog that makes it hard to form a clear thought in the afternoon. The cravings that come rushing back 2 hours after you just ate a full meal. That strange, uncomfortable heaviness that does not feel like normal satisfaction. The energy crash that feels almost impossible to fight no matter how much you rest or how early you went to bed. Now, here is what almost nobody is explaining clearly enough. The problem may not be the carbohydrate itself, it may be how your body is being forced to process it. Because the exact same bowl of rice can hit your bloodstream like a flood of sugar all at once, or it can behave almost like an entirely different food, depending on one small preparation change that most people have never heard of. And once you understand this, you stop seeing diabetes as something that happened to you as punishment, and you start understanding the actual biology driving it. Because that shift matters enormously. Understanding is what creates lasting change. Fear is what makes people quit. So stay with me because what I'm about to walk you through changes the way you look at bread, rice, potatoes, and blood sugar permanently. And I want you watching until the end because the final strategies in this video are the ones most people never hear about, and they may be the most powerful of all. My name is Dr. Megan Foster. I work in preventive medicine and metabolic health. I have spent decades helping patients with type 2 diabetes, prediabetes, and insulin resistance not just manage their condition, but genuinely understand it from the inside out. And the single biggest problem I see over and over again is not a lack of willpower. It is not laziness. It is not even consistently bad food choices. It is that people are told to fear carbohydrates instead of understanding them. The standard advice most people receive is blunt and simple. Just stop eating carbs, cut the rice, avoid the bread, never touch a potato again. And I understand why that advice exists. Carbohydrates do raise blood sugar. That part is true. But for most human beings living real complex lives, completely eliminating carbohydrates long term is not realistic. It is not sustainable. And for billions of people around the world, rice, bread, potatoes, noodles, and grains are not optional extras. They are foundational foods. They are what families cook together. They are what connects people to their culture, their history, and their daily sense of normalcy. And here is what most people never get to hear from their doctor. Two people can eat the exact same amount of carbohydrates and experience completely different blood sugar responses. Not because one has more willpower, not because one has better genes, but because how a food is prepared, what you eat alongside it, the order in which you eat different foods, what you do after the meal, and what time of day you eat, all of these things dramatically alter what happens inside your body. This is not just about what you eat. It is about the entire biological environment surrounding the food, and that changes everything. I want you to think back for a moment, maybe 10 years ago. Maybe 15. You probably ate bread sometimes without thinking twice, rice with dinner a few nights a week, potatoes at family gatherings, and you likely did not feel completely wiped out afterward. You were not anxious about every glucose reading. You were not afraid of food the way many people with diabetes become afraid of it. Now compare that to today. Maybe now you feel sleepy after almost every meal. Your cravings return quickly. Your energy crashes hard in the afternoon. Your glucose spikes even when you thought the meal was healthy. And somewhere along the way, you started telling yourself, my body just cannot handle carbohydrates anymore. I understand why it feels that way. But that is not the complete picture. Here is what is actually happening inside your metabolism. Modern eating patterns have dramatically changed the speed, structure, and intensity of how carbohydrates hit the bloodstream in ways the human body struggles to manage when it happens repeatedly, meal after meal, year after year. Finely processed grains, instant foods, ultra refined starches, foods that are specifically engineered to dissolve almost immediately once they reach your digestive system. These are fundamentally different from the whole, minimally processed grains and starches that humans ate throughout most of history. And once you understand how glucose actually moves from food into your blood and what determines how fast that happens, you can often improve blood sugar control significantly without eliminating the foods you love most. Not overnight, not perfectly, but meaningfully and sustainably. The strategies I am going to walk you through today are grounded in real clinical research, not trends, not internet theories, mechanisms that have been studied, tested, and replicated in peer reviewed trials. So let us start at the very beginning with the biology, because understanding this foundation is what makes every single strategy make sense. When you eat a carbohydrate, any carbohydrate, your digestive system breaks it down into glucose, which is the basic form of sugar your cells use for energy. That glucose moves from your gut into your bloodstream. Your pancreas detects the rise in blood sugar and releases insulin, a hormone that acts like a key, unlocking your cells so they can absorb that glucose and use it for energy. In a healthy, well functioning metabolism, this process is gradual and controlled. Glucose trickles steadily into the blood, insulin responds in proportion, and blood sugar stays within a stable, healthy range. But when carbohydrates digest extremely fast, and many modern refined carbs do exactly this, glucose floods into the bloodstream all at once. Your pancreas has to scramble to produce enough insulin quickly enough to manage the surge. Blood sugar spikes sharply. Insulin surges alongside it. And then in many people, blood sugar drops too quickly afterward, which is what triggers that wave of hunger, cravings, and fatigue just a few hours after eating. This cycle, the spike, the overcorrection, the crash, the craving, is what feels so exhausting and defeating. And what most people do not realize is that this cycle is not just uncomfortable. Over time, it contributes to what is called insulin resistance, where the cells stop responding as efficiently to insulin's signal, requiring more and more insulin to do the same job. And that progressive insulin resistance is at the heart of type 2 diabetes progression. The most important thing I want you to take from this section is simple. This cycle is not inevitable, it is not irreversible. And for most people, it does not require eliminating carbohydrates to address. It requires changing how carbohydrates enter your body. Think of your bloodstream like a highway. Traffic flows best when cars merge gradually at a controlled pace. But when thousands of cars try to merge all at once, you get gridlock. The whole system backs up. That is what a glucose spike looks like inside your body. Freshly cooked refined starches, white bread, straight from the toaster, hot white rice just out of the pot, instant mashed potatoes, send glucose rushing onto that highway all at once. Your insulin system scrambles to control the chaos, and over years, that repeated metabolic scramble accumulates real damage. But when carbohydrates digest more slowly, glucose enters gradually. The traffic flows smoothly, less stress, less insulin demand, less metabolic wear and tear over time. And here's the part that surprises almost everyone in my practice. You can dramatically slow that glucose release simply by changing the temperature of your food, what you combine it with, what order you eat things in, and what you do for 10 minutes after your meal. Same food. Completely different metabolic outcome. Let us go through each strategy one by one. And I want you to notice something as we go. None of these require you to give up the foods you love. They require you to understand them. The first strategy is one of the most fascinating discoveries in nutritional science over the past few decades. It has to do with something called resistant starch, and most people have never heard of it. Most people assume reheated food is somehow inferior, a compromise you make when you did not have time to cook fresh. But in the case of certain carbohydrates, cooling them down after cooking actually transforms them at a structural level in a way that is genuinely and measurably beneficial for blood sugar. Here's exactly how it works. When you cook starch, rice, potatoes, pasta, heat causes the starch molecules to absorb water and swell, making them easy for your digestive enzymes to break down quickly. This is why freshly cooked hot rice raises blood sugar relatively fast. But when you then allow that cooked starch to cool down in the refrigerator, something remarkable happens. The starch molecules reorganize themselves into a tighter, more crystalline structure. Scientists call this process retrogradation, and the product of that process is what we call resistant starch. Resistant starch earns its name because it resists rapid digestion. Instead of breaking down quickly in your small intestine and flooding your bloodstream with glucose, it travels more slowly and more intact through your digestive system. It behaves far more like dietary fiber than like a fast carbohydrate. It feeds the beneficial bacteria living in your gut. It produces compounds called short chain fatty acids, which actually support the health of your gut lining and have been shown to improve how your cells respond to insulin over time. And it significantly reduces both how fast and how high your blood sugar rises after eating. Clinical research has consistently shown that cooled and reheated rice and potatoes produce meaningfully lower glucose and insulin responses compared to the freshly cooked versions of those exact same foods. Multiple studies have measured reductions significant enough to be clinically meaningful. The kind of difference that, repeated at meal after meal over months and years, compounds into enormous long term improvements in metabolic health. What does this look like in practical life? Cook rice in larger batches, not just enough for one meal, but enough for two or three. Let it cool completely at room temperature first, then refrigerate it overnight. When you are ready to eat it, reheat it however you prefer, in a pan with a little oil, in the microwave, steamed briefly. The resistant starch that formed during cooling does not fully revert when you reheat it. A significant portion persists, and your blood sugar response remains meaningfully lower compared to eating it freshly cooked. The same principle applies to potatoes. A freshly baked hot potato has a relatively high glycemic impact. But a potato that has been boiled or baked, cooled in the refrigerator overnight, and then eaten the next day, whether reheated or served cold as part of a salad, contains substantially more resistant starch. Some research suggests the blood sugar impact of cooled potatoes is reduced by as much as a quarter to a third compared to eating them hot. Pasta follows the same pattern. Cooked, cooled, and reheated pasta has a noticeably lower blood sugar impact than pasta eaten immediately after it finishes cooking. This is part of the reason why cold pasta salads, which are common in Mediterranean food traditions, may have a more favorable metabolic profile than a hot bowl of pasta served fresh from the stove. Now, here's the mistake I see people make once they discover this strategy. They start cooling and reheating their rice and potatoes, which is excellent. But then they pour a sweetened sauce on top, add a heavily processed side dish, or drink a sugary beverage alongside the meal. And those additions bring their own rapid glucose load that cancels out a meaningful portion of the benefit they just worked to create. The strategy only works when the rest of the meal supports it, which leads directly into strategy number two: food pairing. This is one of the most powerful and most underused tools in metabolic health. And the science behind it is clear and consistent across dozens of clinical studies. When you eat carbohydrates alone, a piece of bread by itself, a plain bowl of rice, crackers without anything accompanying them, those carbohydrates digest rapidly. There is nothing to slow them down. Glucose enters your blood fast and peaks high. But when you combine carbohydrates with protein, healthy fat, fiber, or acidic foods like vinegar or lemon juice, digestion slows considerably. the stomach empties more gradually. Glucose enters the bloodstream at a controlled, moderate pace. The spike is lower, the drop afterward is gentler. Your insulin system does not have to work nearly as hard. Let me walk through each pairing component separately because each works through a different mechanism, and understanding the why makes you far more likely to actually use it. Protein slows what is called gastric emptying, the rate at which your stomach moves food through into the small intestine. When protein is present in a meal, the whole digestive process slows down. Glucose from the carbohydrates you ate enters your blood more gradually. Eating chicken, fish, eggs, Greek yogurt, cottage cheese, legumes, or even a moderate amount of nuts alongside your carbohydrates substantially blunts the blood sugar response compared to eating those same carbohydrates in isolation. Healthy fats work similarly. Fat slows digestion and delays glucose absorption into the bloodstream. This is why a piece of whole grain bread eaten with avocado raises blood sugar more gradually than the same bread eaten plain. This is why adding a drizzle of olive oil to a meal has real and measurable effects on the post meal glucose response. Fat is not the enemy of blood sugar control. The right kinds of fats, from sources like olive oil, avocado, nuts, seeds, and fatty fish, are genuinely valuable allies in metabolic health. Fiber may be the single most powerful food pairing component of all. Soluble fiber, which dissolves in water, forms a thick gel-like substance in your digestive tract. That gel physically coats the inner surface of the intestine and slows the absorption of glucose from carbohydrates into your blood. Foods rich in soluble fiber, non-starchy vegetables, legumes, oats, apples, berries, flaxseed, eaten alongside carbohydrates create a natural buffer that moderates how fast glucose can enter your bloodstream. And then there are acidic foods. This one surprises many people, but the research is genuinely compelling. Apple cider vinegar, regular vinegar, balsamic vinegar, lemon juice. These have been shown in multiple well-designed studies to reduce post-meal glucose spikes. The mechanism involves the effect of acidity on the enzymes in your gut that break down starch. When those enzymes are mildly inhibited by an acidic environment, starch digestion slows, and glucose enters the bloodstream more gradually. One randomized controlled trial found that consuming a small amount of diluted vinegar before a carbohydrate-containing meal reduced post-meal blood sugar response meaningfully in people with type 2 diabetes. Other studies have shown similar effects with lemon juice added to food. This does not mean you need to drink vinegar by the glass. It means that dressing your salad with a simple vinaigrette or squeezing fresh lemon over your meal is doing more for your blood sugar than most people realize. The practical takeaway for food pairing is this: never eat carbohydrates alone if you can help it. Every carbohydrate containing meal should have a protein source, a fat source, a fiber rich vegetable component, and whenever possible, something with natural acidity. Not because you need to follow complicated rules, but because that combination mirrors what your digestive system was designed to handle. Now let us move into strategy number 3. This one is so simple that many people dismiss it when they first hear it. But the research behind it is some of the most compelling in this entire field. Food sequencing, the order in which you eat different parts of your meal. A landmark study published in a peer-reviewed diabetes journal tested this directly. One group of participants ate carbohydrates first during a meal, then protein and vegetables. A second group ate the exact same foods in reverse order. Vegetables and protein first, carbohydrates last. Same foods, same portions, same total calories. Different sequence only. The group that ate vegetables and protein first experienced post-meal glucose spikes that were dramatically lower. Some measurements showing reductions of roughly 40% compared to eating carbohydrates first. 40%. From changing nothing but the order. The mechanism is elegant. When you eat vegetables first, the fiber they contain begins forming that slowing gel in your gut before the carbohydrates arrive. When you eat protein and fat next, Gastric emptying slows further. By the time the carbohydrates reach your small intestine, the entire digestive environment has already been conditioned to absorb glucose gradually rather than explosively. You are essentially pre treating the digestive highway before the glucose traffic arrives. The practical application is simple. At every meal, start with the vegetables, your salad, your leafy greens, your non starchy cooked vegetables. Then move to your protein, the meat, the fish, the eggs, the beans. Then eat the rice, bread, potato, or pasta last. And here's something interesting that many people notice once they start doing this. When you eat in this order, you often naturally eat a little less of the carbohydrate portion, not because you're forcing yourself to restrict, but because the protein and vegetables have already started creating satiety signals by the time you get to the carbs. The sequencing strategy tends to naturally moderate carbohydrate portion size without any deliberate effort at restriction. Now, let us pause for a moment because I want to hear from you. What carbohydrate do you miss the most or struggle with the most? Is it rice, bread, potatoes, pasta, something else entirely? Because one of the core purposes of this channel is helping people feel less trapped around food while genuinely improving their health. And that starts with acknowledging that these foods matter to you, not just nutritionally, but emotionally and culturally. You are not alone in that. Leave it in the comments below. Moving to strategy number 4. And this one is unique because it has nothing to do with food preparation at all. Post meal walking. One of the most underrated and immediately accessible blood sugar management tools available to anyone is a short walk after eating. Not a long, difficult workout, not a gym session. A 10 to 15-minute walk at a comfortable conversational pace within 30 to 60 minutes of finishing a meal. Here is exactly why this works. When your muscles are moving, they can absorb glucose directly from your bloodstream through a mechanism that does not require insulin at all. Scientists call this insulin-independent glucose uptake. Your muscle cells contain protein transporters, essentially tiny doorways, that move glucose from the blood into the muscle cell for use as energy. During physical activity, these transporters activate automatically without needing insulin to trigger them. The muscles open their own doors and pull glucose in directly. One muscle, in particular, the soleus, located deep in your calf, is exceptionally active during walking and has an unusually large capacity for this kind of direct glucose absorption. It is what scientists call a slow twitch muscle, meaning it is designed for sustained low intensity activity and can work for long periods without fatiguing. So, when you take a 10-minute walk after a meal, your soleus and surrounding leg muscles begin pulling glucose from your bloodstream at almost exactly the moment glucose is peaking from digestion. Instead of that glucose circulating at high levels and demanding an insulin response, it gets redirected into working muscles that are using it for energy in real time. Multiple clinical studies confirm that a short post meal walk reduces blood sugar spikes more effectively than the same duration of walking performed at other times of day. The timing is what creates the effect. Walking specifically during the window when food is being digested, roughly 30 to 90 minutes after eating, captures the glucose before it peaks. And you do not need to walk fast. A gentle, unhurried stroll is enough to produce a meaningful difference. Some research even shows that simply standing up and moving lightly around your home after a meal is meaningfully better for blood sugar than sitting still. For people who tell me they are too exhausted after eating to walk, here's the important irony. The post meal fatigue you feel is very often a direct symptom of the glucose spike itself. The walk reduces the spike, which reduces the fatigue. So, the very reason you feel too tired to walk is the thing the walk prevents. Now, let us move into something I want to spend meaningful time on because it fundamentally changes how you should be looking at food labels and making food choices. This is the difference between glycemic index and glycemic load. And most people only know the half of this picture. You have probably heard the term glycemic index. It is a ranking system that measures how quickly a food raises blood sugar compared to pure glucose. Foods with a high glycemic index raise blood sugar fast. Foods with a low glycemic index raise it more slowly. That sounds straightforward. But here's the critical piece that most popular explanations leave out. Glycemic index is measured using a fixed amount, specifically 50 grams of available carbohydrate from a food. But many foods that score high on the glycemic index do not actually contain 50 grams of carbohydrate in a realistic serving. Watermelon is the most famous example. Watermelon has a high glycemic index score, which led many sources to advise people with diabetes to avoid it. But a normal serving of watermelon contains very few grams of actual carbohydrate because watermelon is mostly water. The real world blood sugar impact of eating a reasonable portion of watermelon is quite modest. This is where glycemic load becomes important. Glycemic load accounts for both how quickly a food raises blood sugar and how much carbohydrate a realistic serving actually delivers. It gives you a far more accurate picture of what a food will do to your blood sugar in real life. Carrots are another classic example. Raw carrots have a moderately high glycemic index score, which led many well meaning health sources to advise diabetics to minimize them. But a normal serving of carrots contains very few total grams of carbohydrate. The glycemic load is low. Avoiding carrots because of their glycemic index score is, in practice, unnecessary, and it deprives people of an extremely nutritious vegetable. Understanding this distinction protects you from making unnecessarily restrictive food choices based on incomplete information. A food's glycemic index alone does not tell you the full story. How much you eat, what you eat it with, how it is prepared, and the glycemic load of the overall meal are all far more informative than any single number on a chart. Now, I want to move into a topic that has received enormous scientific attention in recent years and that I believe every person managing blood sugar should understand: the gut microbiome and its relationship to blood sugar control. Inside your digestive system, particularly your large intestine, lives a vast and complex community of bacteria, trillions of them, along with fungi and other microorganisms. This community is called the gut microbiome. And over the past decade, researchers have discovered that the composition of this community has a profound effect on metabolic health, including how your body handles glucose. People with type 2 diabetes tend to have a significantly different gut microbiome compared to people with healthy blood sugar. Specifically, they tend to have lower populations of certain beneficial bacterial species and higher populations of bacteria associated with inflammation and metabolic disruption. Why does this matter? First, certain gut bacteria produce compounds, particularly short chain fatty acids, that improve how your cells respond to insulin. When you eat fiber and resistant starch, you are feeding these beneficial bacteria. They ferment that fiber and resistant starch and produce these protective compounds as a natural byproduct. This is one of the reasons that higher fiber intake is consistently associated with better blood sugar control across large population studies. It is not just about slowing glucose absorption. It is also about continuously supporting the bacterial communities that improve insulin sensitivity over time. Second, an unhealthy gut microbiome is associated with higher levels of chronic, low grade inflammation throughout the body. And that chronic inflammation directly interferes with insulin signaling. When cells are chronically inflamed, they become less responsive to insulin's signal. This creates a damaging cycle. Poor metabolic health disrupts the gut microbiome. The disrupted microbiome drives more inflammation. The inflammation worsens insulin resistance, which further disrupts the microbiome. But the reverse is equally true. When you consistently eat more fiber, include fermented foods, reduce ultra processed food consumption, and support the diversity of your gut bacteria, the microbiome gradually shifts toward a more favorable composition. Inflammation decreases, insulin sensitivity improves, and blood sugar control becomes meaningfully easier over time. Over Fermented foods in particular, natural yogurt with live cultures, kefir, kimchi, sauerkraut, miso, introduce beneficial bacterial strains directly into your gut and have been shown in research to improve microbiome diversity and reduce markers of systemic inflammation. Including these foods consistently is a meaningful metabolic strategy, not just a wellness trend. Now, let us talk about something that is almost entirely overlooked in mainstream diabetes education: the role of muscle mass in blood sugar control. Your skeletal muscle, the muscle attached to your bones that allows you to move, is actually the largest glucose storing tissue in your entire body. When insulin signals cells to absorb glucose from the blood after a meal, skeletal muscle is the primary destination for a large portion of that glucose. It is stored there as glycogen, a form of stored energy that muscles draw on during physical activity. What this means practically is that the more muscle mass you carry, the more capacity your body has for absorbing and storing glucose. More capacity means glucose is cleared from the bloodstream more efficiently after meals. It means your body is more insulin sensitive overall. It means your baseline fasting glucose tends to be lower. People who have significant loss of muscle mass, which becomes more common naturally with age and is dramatically accelerated by prolonged inactivity, often find blood sugar control progressively harder, even without any meaningful change in what they eat. The glucose absorbing capacity of the body has literally shrunk. This is why resistance exercise, lifting weights, doing bodyweight movements, using resistance bands is such an important component of long term blood sugar management. It is not just about burning calories during a workout session. It is about building and maintaining the very tissue that is most responsible for clearing glucose from your bloodstream after every meal. Even modest increases in muscle mass, achieved through regular resistance training 2 to 3 times per week, can produce meaningful improvements in insulin sensitivity and glucose regulation. And the benefits are not limited to young people. Research consistently shows that older adults with diabetes experience significant improvements in blood sugar control from resistance training programs, even when started in their 60s, 70s, and beyond. This does not mean you need to become an athlete. Body weight squats in your living room, resistance band exercises while watching television, carrying groceries instead of using a cart, walking upstairs instead of taking an elevator. These all count. The body responds to the demand you place on muscle in whatever form that takes. Now let us talk about something that many people have never connected to blood sugar at all: hydration. Dehydration has a direct and measurable effect on blood sugar levels. When you are not drinking enough water, the volume of fluid in your bloodstream decreases. The same amount of glucose is now dissolved in a smaller volume of fluid, which means blood sugar readings go up. Not because you absorbed more glucose, but because the existing glucose has become more concentrated. Additionally, when the body is dehydrated, the kidneys become less efficient at filtering and excreting excess glucose through urine, which is one of the body's backup mechanisms for managing elevated blood sugar. And a hormone called vasopressin, which the body releases when it needs to conserve water, has been linked in research to higher fasting glucose levels and increased insulin resistance when chronically elevated. One large observational study found that people who consistently drank less than about half a liter of water per day had meaningfully higher rates of developing elevated blood sugar compared to those who stayed well hydrated. This is a free, immediate, zero complexity intervention that enormous numbers of people are completely missing. Practical application: drink water steadily throughout the day. Start the morning with 1 or 2 glasses of water before any food or coffee. Keep water visible and accessible as a consistent reminder. Drink water specifically with and around meals, not sugary beverages or juice that carry their own glucose load. Replacing even one sugary drink per day with plain water is a significant metabolic change. The glucose contribution of regular soda, sweetened fruit juice, and flavored drinks is substantial. And liquid calories are particularly problematic for blood sugar because they digest almost instantaneously with no fiber or protein present to slow their absorption. Now, I want to introduce a concept that I find genuinely fascinating and that has changed how I counsel patients about meal planning from morning to night. It is called the second meal effect. Researchers discovered something unexpected when studying blood sugar responses across multiple meals in a day. What you eat at breakfast significantly affects not just your blood sugar after breakfast, it affects your blood sugar after lunch as well, even hours later, regardless of what you eat at lunch. A breakfast that produces a gradual, moderate glucose response creates a more favorable metabolic environment for the entire mid morning period. It improves insulin sensitivity for the hours that follow, and it meaningfully blunts the glucose spike from your next meal, even if that next meal is identical to what would have caused a larger spike after a less ideal breakfast. The mechanism behind this involves compounds called incretins, hormones your gut releases in response to eating that regulate insulin secretion and slow digestion. A fiber rich, protein adequate breakfast supports a sustained incretin response that remains active for several hours, benefiting not just the meal that triggered it, but the metabolic environment surrounding the next meal. What this means practically, breakfast sets the metabolic tone for the entire first half of your day. A breakfast built around eggs and vegetables, Greek yogurt and berries, oats with nuts and seeds, or whole grain toast with avocado and a protein source creates a very different physiological environment than a breakfast of sweetened cereal or white toast with jam, even if both have similar calorie counts. For people who say they are not hungry in the morning, which is genuinely common and often a result of late night eating suppressing morning appetite, the second meal effect is a strong argument for at least consuming a modest, well composed breakfast rather than skipping it entirely. The downstream effects on blood sugar through the entire morning are real and measurable. Now, let us talk about something that most conversations about blood sugar and diet completely overlook: the mineral magnesium. Magnesium is involved in over 300 different biochemical processes in the body, and one of its most important roles is in insulin signaling. Magnesium is required for the insulin receptor on your cells to function properly. The receptor is the molecular structure on the surface of a cell that receives insulin's signal and tells the cell to open its doors to glucose. When magnesium levels are low, these receptors become less responsive. The signal does not transmit efficiently. Cells do not absorb glucose as readily. Insulin resistance quietly worsens. Research has found that people with type 2 diabetes are significantly more likely to have low magnesium levels than people without diabetes. And large observational studies show that higher magnesium intake from food is consistently associated with lower risk of developing type 2 diabetes and better blood sugar control in people who already have it. Where does magnesium come from in food? Dark leafy greens, spinach, chard, kale, pumpkin seeds, black beans, and other legumes, whole grains, almonds, avocado, dark chocolate with high cocoa content. These are foods that support metabolic health in multiple overlapping ways simultaneously. It is also worth understanding why so many people are low in magnesium. Refined and heavily processed food diets tend to be very low in this mineral because the processing and milling of grains strips away much of their mineral content. White flour, for example, has lost most of the magnesium present in the original whole wheat. This is another layer of why ultra processed diets are metabolically harmful. It is not just the sugar and refined starch. It is the quiet depletion of minerals that the body's insulin system depends on to function properly. Let us now go deeper into meal timing, because there's an important aspect of this topic I have not fully covered yet. The concept of time restricted eating has received enormous scientific attention in recent years, and for people with diabetes and prediabetes, some of what the research shows is genuinely worth understanding clearly. Time restricted eating simply means concentrating your daily food intake within a defined window of hours and then fasting naturally for the remaining hours of the day. For example, eating between 8 in the morning and 6 in the evening, a 10-hour window, and then not eating again until the following morning. Multiple clinical trials have shown that time restricted eating, even without any deliberate change in the types or total amounts of food consumed, can improve insulin sensitivity, reduce fasting blood glucose, and decrease markers of metabolic stress in people with type 2 diabetes and prediabetes. Why would simply changing when you eat without changing what you eat improve blood sugar? Part of the answer goes back to the body's circadian rhythm, the internal biological clock that regulates almost every physiological process. Your insulin sensitivity follows a predictable daily pattern. It is typically highest in the morning and early afternoon, and it declines progressively through the evening. Your cells are genuinely more responsive to insulin's signal earlier in the day. Concentrating eating in the earlier, more insulin sensitive portion of the day and allowing a longer overnight fast gives insulin levels time to come down fully between meals. It gives cells a genuine rest period during which they can restore their sensitivity to insulin's signal. And it prevents the continuous low level insulin stimulation that drives insulin resistance when eating is spread from early morning all the way to late at night. The liver also benefits significantly from an extended fasting window. The liver plays a central role in glucose regulation overnight, releasing stored glucose gradually to maintain blood sugar while you sleep. When you eat late and eat frequently across a long window, the liver remains in an active metabolic state well into the night. An extended fast gives the liver time to complete its glucose regulation cycles fully and reset, which often translates directly into lower morning fasting glucose readings. For people who track their morning fasting glucose and find it frustratingly high, even after eating carefully the day before, late night eating and a compressed overnight fast are very often the hidden variables that nobody explained to them. I also want to explain something called the dawn phenomenon because it comes up constantly with patients, and I want to give you a clear, practical understanding of it. Even without eating anything, many people with diabetes notice that their blood sugar rises in the early morning hours, sometimes beginning around 3 or 4 in the morning, well before they wake up. This happens because during those pre dawn hours, the body naturally releases hormones, including cortisol and growth hormone, that signal the liver to release glucose into the bloodstream. The body is essentially preparing you with energy for the day ahead. In people without diabetes, a modest insulin response handles this glucose release smoothly and blood sugar remains stable. In people with diabetes or significant insulin resistance, that response is impaired and blood sugar rises noticeably before breakfast. Understanding the dawn phenomenon matters because it means your fasting morning glucose is not entirely within your dietary control. It has a hormonal component that is part of your body's natural rhythms. But earlier dinner timing, lighter evening meals, and reducing carbohydrate intake late at night can all reduce the total glucose burden going into that overnight window, which can modestly but meaningfully improve morning numbers over time. Now, I want to speak directly to something I know is on many minds. If you are currently taking insulin or glucose lowering medications, any meaningful dietary change that genuinely improves your blood sugar control needs to be monitored carefully with your doctor or diabetes care team. That is not just a legal disclaimer, it is medically important. If the strategies we have covered today begin working well, if your post meal glucose responses become more moderate, if your fasting numbers start improving, your medication requirements may change. That is a genuinely good development, but it is one that needs medical supervision. Please make your care team part of this process. Now, let me bring everything together into a complete picture. The strategies we have covered are not separate, isolated tips. They function as an interconnected system, and the cumulative effect is far greater than any single change alone. You begin by choosing carbohydrate foods that are less processed, whole grains with their original structure intact, legumes with their high fiber and resistant starch content, minimally refined starches, because the physical structure of the food before you even cook it determines the baseline speed of glucose release. You prepare those carbohydrates thoughtfully, cooking and cooling rice, potatoes, and pasta to build resistant starch before reheating them. Because preparation method can meaningfully shift the blood sugar impact of the same food. You build every meal around protein, healthy fat, fiber, and something acidic, because that combination creates the digestive environment that slows glucose absorption before it ever reaches your bloodstream. You eat in the right sequence: vegetables first, protein second, carbohydrates last, because the order of eating changes the biological environment of your gut in real time. You move after eating, a short, gentle walk, because muscle activity draws glucose from the blood at the exact moment it is peaking without requiring insulin. You time your meals thoughtfully, eating larger meals earlier in the day, keeping evening meals lighter, finishing eating at a reasonable hour, and giving your body an extended overnight fast when possible. You support your gut microbiome through fiber, resistant starch, and fermented foods, because the bacteria in your gut actively and continuously influence how your cells respond to insulin. You protect your muscle mass through regular movement, including some resistance training, because muscle is the primary site of glucose storage and the most important biological driver of long term insulin sensitivity. You stay well hydrated, because dehydration concentrates blood glucose and impairs the body's ability to manage it. You pay attention to your breakfast, because what you eat in the morning sets the metabolic environment for the entire first half of your day through the second meal effect. You ensure adequate magnesium through whole foods, because without sufficient magnesium, your insulin receptors cannot function properly regardless of how well everything else is aligned. And you take seriously the management of sleep and stress, because no dietary strategy can fully compensate for chronically elevated cortisol from unmanaged stress or for the insulin resistance created by chronic sleep deprivation. This is what working with your metabolism actually looks like. It is not a single rule or single restriction. It is a system. And systems are far more powerful and far more sustainable than any individual rule ever can be. Now, let me speak directly to the obstacle that I see destroy long term progress more consistently than almost anything else: perfectionism. Many people approach diabetes management the way they approach a crash diet. They go completely all in. They follow every guideline flawlessly for a week, 2 weeks, maybe a month. And then life happens: a family gathering, a holiday, a brutal week at work. They eat something outside their plan. And instead of simply continuing the next day, they conclude that they have failed Ajit, and they abandon the effort entirely. This pattern is painful to witness because it is so unnecessary. Blood sugar management is not a test you pass or fail. It is a biological process that responds to average patterns over time. One imperfect meal does not undo weeks of consistent effort. One difficult week does not erase months of progress. The biology genuinely does not work that way. Your body accumulates the benefits of consistent habits across time, and it is far more forgiving of occasional imperfection than most people believe. A person who follows these strategies 80% of the time for 2 years will have far better metabolic health than someone who is perfect for 3 weeks and then stops. That is not permission to be careless. It is permission to be human and to simply continue. Understanding is what makes that kind of sustained consistency possible. When you know why these strategies work, you can adapt them to real life. You can make a conscious, informed choice in a challenging moment, recognize what the trade off is, and return to your habits immediately afterward, without guilt, without shame, without the all or nothing spiral that undoes so much genuine progress. Fear leads to restriction. Restriction leads to rebellion. Rebellion leads to guilt. Guilt leads to abandonment. Understanding leads to flexibility. Flexibility leads to consistency. And consistency, sustained over time, is what actually changes metabolic health in ways that last. Your body is not broken, it is responding precisely, predictably, and logically to the inputs it receives. Change those inputs thoughtfully, systematically, and consistently, and the outputs change accordingly. You deserve to eat food without living in fear of every bite. To understand what is actually happening in your body rather than just being handed rules to follow. To manage your health with knowledge rather than with anxiety, and to feel genuinely well, stable, energized, and in real control of your own biology. So here's the challenge I want to leave you with for the next 7 days. Choose just one strategy from everything we covered today, not all of them. One, maybe you cook a batch of rice tonight, refrigerate it, and eat it reheated tomorrow and see how different you feel afterward. Maybe you commit to eating your vegetables first at every meal for 7 days. Maybe you take a 10-minute walk after dinner every evening this week. Maybe you swap your usual breakfast for something built around eggs and vegetables or Greek yogurt and berries. And notice how your energy holds through the entire morning. Maybe you drink a full glass of water with every meal this week. Maybe you make dinner a lighter meal and finish eating an hour earlier than you normally do. One strategy, 7 days, consistent practice. Then pay attention to what shifts your energy, your cravings, the heaviness after meals, your glucose readings if you monitor them. Small biological changes applied consistently accumulate into enormous long term effects. That is not motivational language. That is the literal mechanism of how metabolic health improves, one repeated, well understood action at a time. If you want to continue going deeper into metabolic health, longevity, inflammation, hormones, and aging well, the longevity guide linked below is the best place to take the next step. Everything there builds directly on what we covered today. I will see you in the next video.